color C. Let's spin to rod CD while it slides on rod AB. If the rod AB has an angular velocity of 2 radians per second and an angular acceleration of 8 radians per second squared, both acting in the counterclockwise, like as shown in the picture, determine the angular velocity and the angular acceleration, of rod CD at the instant shown. All right, so I'm not going to draw a free body diagram for this because it's not going to be super useful, but we understand, right, the problem that we have this bar here, right, that's going to be rotating upwards, right? So we expect member DC to move upwards, right? And yeah, so let's get started with this. So my first step is going to basically, so basically I'm going to have, this is a bigger, it's not like the problem I did previously. This is going to require us to have an axis that is rotating, right? And I'm going to choose to place it right here. So let me just pick a better color. All right, so this is going to be X, this is going to be Y. All right, so I'm just going to remind you guys of the equations I'm going to be using. So VC, right? So if I want the velocity of C from point D, for example, I would do VD, right? Plus the velocity coming from the angular component plus V DC, right? Oh, wait, sorry. It's all CD, not DC. CD, right? Coming from the rotational frame. So basically, in our frame that's rotating, what's the velocity? We see this going around, right? And the other equation I'm going to be using is the acceleration one. Very similar, right? So we have EC AD plus alpha R CD, right? So I'm going to use, so if I don't know if you guys have the same notation, but this is the same thing as omega, but specifically the one from the rotating reference frame. All right, so that makes CD here. Right, and then we have the Coriolis term, which is 2 big omega times the velocity of C with respect to the rotational frame plus the acceleration CD from the rotational frame. Right, therefore, these will be the two equations that we will need to use. And this is not a dot product, this is cross product like this. And yeah, and basically, in this problem, what I'll be doing is doing it up from C to D, right? And then from A to C. That way I have two different equations and I'll be able to make them equate each other and find my unknowns. All right, so now we can keep going, right? So as I said previously, the first thing I'm going to do is I'm going to do from D to C. So I'm going to reuse this same equation here. Right, and I know the velocity of D, right? It's a pin here. So here it's a pin, so I know that the velocity is going to be 0. And I also know that CD has the point C pin, right? Which is what is said here. Therefore, I can also say that's 0. And I am just left with VC equal omega CD RCD, right? Which we know is 0, 0 omega cross. So now I gotta come here, and we know that the distance basically is just 1 meter in the x direction, right? Because we have to reference this. Therefore, this is only going to be minus 1, 0, 0, right? Because we're going from D to C, so from here to here. So we're going the negative x direction. Therefore, our answer at the end, so once you do the cross product, you will get minus omega j. All right, so that's going to be, we'll call it I guess. Going to be our equation I, and then I'm doing the same thing again, but this time I'm going to do from A to C. All right, so what I'm going to do is I'm going to copy this equation, but instead of starting from D, I'm going to start from A. A, A, A. All right, once again, if we go here to A is a pinned equation, right? Therefore, this goes to 0. And this might not be 0. We don't know because it could be moving, right? And therefore, we have VC 0, 0 omega cross RCA, which again, if we're going from A, right, from A to C, it's 1.5 in the x direction. This one will be positive, 0, 0. Right? And we know that VCA is going to be in the, because it's a color, it's going to be in the I direction, right? And then putting this together, we know that VC is going to be equal to 1.5 omega plus VCA I, and this is also J. All right, and now we're good to get the next step, which is mixing these two equations together, right? So I'm just gonna bring this one here down here. All right, so it's gonna be minus omega J, 1.5 omega J plus omega CA I. Right, therefore, sorry, it's a V. Therefore, I know that oh yeah, important thing, right? This I should have made be more careful here. So this is CD, right? And this one here is not CD, is CA. All right, so these two are two different omegas, right? Therefore, since we have here omega CD, right, and omega CA, we are able to find the other one. So let me just rewrite this as CD, CA, right? Therefore, if we equate the G hats, we know that. So the one we know, the one that's given is WAV, right? Which is the same as WAC in my case. So I want to know what WCD is, which is minus 1.5 times WCA, which is minus 1.5 times 2 radians per second, which is minus 3 radians per second. Right? And if we equal the I, we know that 0 equals VCA, which is also helpful. Right? And now we do the same thing, but using the acceleration. I'm going to copy this equation here. Copy, paste. All right. We know that acceleration of d is going to be 0 because it's a pin. All right. We also know that VCD is 0 because it's not moving, right? It's pinned to it. Same thing with the acceleration. Therefore, we have AC is going to be equal to 0, 0. So once again, this is the CD one, right? Cross minus 1, 0, 0. Plus, and then this one here, that's going to be the same one as omega CA, right? Which is the one of the rotating frame. Therefore, I am going to have, and this result is the same we had before, right? So it's going to be 0, 0, WCA cross 0, 1.5 WCA 0, right? Which is the result I put here before. All right. And then, yeah, then we cross multiply everything. We have minus alpha CD, J, of course, plus not plus, sorry, minus omega squared CA 1.5, right? In the J direction, right? Sorry, the I direction, right? Because this is going to be 0, 0, WCA, 0, 1.5 WCA, right? 0. So the I is going to be this, which is a negative squared. All right. Cool. Oops. All right. Once we're done with this, so we know that this is AC. We're going to do the same thing as before. All right. So let's call this tree just so it's a bit clearer. I'm going to use this one here, but this time starting from A instead of D, right? A, A, A everywhere. Perfect. So A is a pin. Oops. A is a pin. All right. So A is a pin, right? So that goes to 0. The expression might not be 0, but we know that this is 0. Right? We found that before. And we know this, we know this, we know this. We know this, but we don't know this. Actually, we know this too, right? Because this is alpha CA, right? And this again is omega CA, because the one that's given in the problem. So we know that AC is going to be equal to 0, 0 alpha CA cross 1.5, 0, 0 plus 0, 0 omega CD. Sorry, not CD, CA. All right, and we know this thing from before, which is when we did this thing here. So we know it's just equal to this. So 0, 1.5 omega CA 0 plus the acceleration that we know, right, is only in one direction, the I direction, because it's a color. And then expanding everything, we have 1.5 alpha CA j hat minus 1.5 omega CA squared I hat plus ACA I hat, right? And therefore, we go back to, okay, let me space this out a little bit better. And then we go back to this one here, we bring it down here. So we will have this equals this here. All right. Therefore, if we equate, right, and we know in this equation, we know what alpha CA is. We know what this is. We know what this is. All right. Therefore, yeah, and we are asked the angular acceleration of rod CD and the angular velocity, right? Therefore, we can figure this out just using J. And so if you use J, we have minus alpha CD can be equal to 1.5 alpha CA, right? Sorry, alpha CA as a subscript, right? Therefore, alpha CD is going to be minus 1.5 alpha CA, which is minus 1.5 times, as given in the question here, 8 radian per second squared, which is equal to minus 12. Minus 12 radians per second squared, right? And then, of course, if we wanted to find, using hi-hat, we could find the acceleration of a, given the reference frame, right? Basically, we know it's minus 1.5 omega CA equals minus 1.5 omega 2 CA plus AC, right? This cancel, therefore A equals 0, right? And our final solution, basically, since we're only asked for alpha CD, minus 12 radian second squared, and for omega CD, which we found previously in here to be minus 3 radians per second, right? And this is the answer. And they're both counterclockwise, of course. Sorry, clockwise. All right, which makes sense, right? Because if we imagine this bar going this way, we imagine this one going this way, and if it's going that way, it's rotating this way, which is clockwise.